Okay. Looks like Sukhvinder, you are the only hope we have. Okay, let me make you the organizer. Is that okay, Sukhvinder? All right. Okay, so we have started the recording, and Sukhvinder, please confirm once you also have started the recording. Great, great. Okay, so instead of going with Hive today, I want to go with NoSQL and HBase. Okay, and the reason is I believe that Hive class we have needs a bit of upgrade. Therefore, I'm postponing Hive right now and moving on to NoSQL and HBase. All right, great. So, in very simple words, the way we had Pig, in the similar fashion we have Hive, exactly same thing as Pig. The way we were writing data churning using Pig, we could do the same thing using Hive. That's what, instead of using SQL, instead of using Latin. Okay, so let's, okay, Leela, you haven't missed anything. All right, great. So today we are going to discuss NoSQL and HBase. All right, all right, great. Okay, you don't need. So we will discuss all the details about the NoSQLs in general, and then we will dive deep into HBase. Okay, we will dive not very deep, good enough that you can design the structure of your HBase table based on your problem statement. Okay, so how do you basically NoSQL? If you have no clue about SQL, you can say confidently that you know NoSQL and you are an expert at NoSQL. All right, so that's kind of one agenda. Great. Okay, but that doesn't mean that if you know SQL, that means you are not expert at NoSQL. All right, great. So first, I want to differentiate, before we dive deeper, I want to differentiate between few things. One, what does it mean by scale out and scale up? Okay, the other name for scale out is horizontal scaling, and scale up means vertical scaling. Okay, so I'll use scale out and scale up. What does it mean? Let's say you had one, so let's say you had one cart with one single horse, and tomorrow you need to carry a bigger load, right? So you have two choices. One, you upgrade your cart such that you can add two horses, or you upgrade your cart such that you can put the elephant instead of the cart. Okay, so if you put an elephant instead of the horse, if you put an elephant instead of the horse, then we call it scale up, meaning you remove the horse, put the elephant. In case you add one more horse, that's scale out or horizontal scaling. Now, earlier days, in the similar way, if your server is suffering from resources, one quick way If your server is slow, is not able to cater to the users, one way was upgrade the hardware, meaning upgrade the horse to an elephant. Remove the horse, add an elephant. Or remove the horse and add a very strong horse, buy the costliest horse available in the market. And honestly, that was the approach all of us followed till recently. If we had one more requirement of CPU uh, and 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 the resources, what would we do is we will just beef up our machine. We will add a bigger machine, but the data will remain the same. So this analogy is very important. Okay, I've seen this happening quite often, and the people who are from the server background, from the data center management background, would be able to understand this clearly. That we would we generally went for hardware upgrade. We would buy the costliest available server in the industry and would chest thump that we had the most powerful machine in our server. This is called scale up. And what changed with this new coming upcoming technologies that we realized that scale up did not help. Therefore, we need to scale out. Vertical scaling was not a solution. Instead, horizontal scaling was. You will see it very soon. Okay. Now, this is something which I want everyone to pay close attention to. This is something, if you have been working in industry since, say, 2002 onwards, you must have seen this happening in your organization often. Okay. Specifically, if you are into the B2C, as in business to consumer. Okay. So you have this great, so this is about a common story which happened quite often in 2000s. And the story starts with you have this brilliant idea, you built a great product, and then you did a launch. You are very happy with your initial public launch. All you did was you moved the server from local machine to a public DMZ server. DMZ as in demilitarized zone, as in a web server. Okay, and you are like, you open the bottle of champagne, and everybody's happy that you have done a public launch. Okay, so you are very happy with your MySQL instance with a perfect, well-defined schema, having perfect tables, having perfect relationships, and having perfect constraint and stored procedures and the triggers and everything the way you have been taught in your school, in your database class. So you are really happy that you did this public launch. Everybody wants to use your service now. Now, in couple of days, what happens is your service starts becoming popular, and there are suddenly, next thing you know is there are too many reads hitting the database. Not a big problem. We have seen this kind of scenarios quite often. So what we do is we put a caching server. Caching server, caching, what is a caching server? Something which records what it gave the last time, so that the next user is given the same thing instead of recomputing. So if there is something which is being recomputed again and again, what you do is you start keeping pre-prepared something upfront. Okay, a copy of it, something pre-prepared. And how do you do generally? You use a tool called memcached. Memcached is itself a data store in which the you can put key and value in a complex format. So no big deal, you added a cache server, but something you violated. And what is that you violated after adding a caching? If and caching layer, surprisingly, none of us feel that it's a bad thing. We feel that this is the greatest design pattern we have. Why? Because it saves our life, but it kills the consistency. How does it kill the consistency? Let's say you updated a customer profile into a cache server, which means every time there's a request for a customer detail, you just serve it from the memcached. Okay, you don't go till the database to fetch all the detail, assemble it after querying, form the object. Instead, you just query the memcached for get the full object and give it to the user. And memcached is faster because it has got everything ready in the memory. Now, what happens when you add a caching layer? You add it inconsistency. And how does it happen? It happens because It happens because your reads are no longer strictly ACID. What is ACID? ACID are the four properties every database should have, every transaction should have. ACID A for atomicity. Anybody quickly? Let me have a look. How many of you? What is ACID? Yeah? All right. Let me take a look. Consistency, atomicity, integrity. Okay. Brilliant. Durability, integrity. Brilliant. So yes, those are the four properties a database is supposed to have. So these four properties are something every database administrator or DBA abide by. It's like it's like the meaning of life and everything for a DBA. Okay, so now the moment you add a caching layer, what happens is your data is at two places, one in the database, other in the cache. And when somebody changes this data, which is in the cache, it takes some time to update the memcache. It takes some time to update the memcache, which means by the time the database gets updated, you are serving the older data. You're serving the older data than what you have in the database. And that becomes a problem. If there is an object which is frequently updated, you will get inconsistencies. Okay, that means adding a caching layer actually hurt your consistency. Correct? Third, the service continues to grow and too many writes are hitting the database. So no, not a big problem, not a big problem. All we do is we beef up our MySQL server. We put lots of hardware, lots of hardware in your database. You put like 16 cores and 128 GB RAM. Now there are 200 GB RAM servers as well available, and banks of 15,000 RPM hard drives, and so on. A usual hard drive is generally 5400 RPM, but on the server grade you have hard drives up to 15,000 RPM. So you put the costliest hardware in your database server because that's all you can do right now. Okay, and then again, you're pretty happy. You're pretty happy that oh, wow, you are able to scale your server and everything is just normal again for some days. For some days, and in these days what you do is you get some VC funding, and once you get the funding, what you start doing is you start adding more and more VPs of various verticals in your website. And what these VPs do is they add more and more features. Somebody wants a discount feature, somebody wants a EMI feature on your website, and so imagine that it's an e-commerce website and everybody you hire is for various kinds of verticals, and what they do is they add more and more features. Somebody comes up with the like Amazon Prime, somebody comes up with the idea of let's do book rentals, and all of these people, all of this development happening impacts your complexity. You keep on adding more and more tables and more columns into your product details page, and everything. So effectively, your new features start adding to your query complexity. Now you have too many joins to serve a product detail page. For example, when you buy something from Flipkart or Amazon, you get to this product page where you go through all the details. Now here you see there are so many functionalities. You have header, you have title, you have image, you have, so I'm telling, giving this example because I've seen this happening at many places in my own personal experience. Now, while on one hand your data is increasing, other hand your number of customers are increasing, that means more number of requests are coming in. Now the other hand, the complexity is increasing. Okay, so when you have so many joins just to serve one single page, what you start doing is you start forming a single table so that you don't have to do so many joins. You start merging multiple tables into one, and removing the table so that you don't have to do the joins. Now, at this point of time, if you are a DBA, you will get kind of a heart attack seeing that this is something I was not taught at DBA school. Because first you let go of the consistency by putting a caching layer. Second, you have let go of, you are letting go of the joins, the normalization feature of the table, of the database. Okay, now still, while you are recovering from this kind of uncomfortable situation, still your marketing people, digital advertising people are marketing your website. There's a PR team going around and more publicity happening. Users are telling about your great website to each other. Now that is again swamping your server. And what you do in these circumstances, when your server is becoming swamped, you stop doing server side computation. You stop doing every server side computation. Okay, what is server side computation? You have stored procedures sitting in your server, as well as in your queries. You would see a lot of times somewhere you're translating date time into the local time zone of the user, and somewhere you are converting the currency into local currency in your SQL. Somewhere you are basically doing some kind of cleaning up the strings into some well formatted one. So all of these computations you start removing from your SQL. Let it be done by the client machine on the client side. Okay, similarly you start removing triggers and other things. And at this point of time, if you see, there are a lot of things which is against what we were taught. Lot of things here are something which a DBA kind of swears by, abides by, and something is really a horror for a DBA. And why is this happening? Just to handle the load. Okay, now, and I have seen it happening. And for the first time, when I was at DE Shaw, and we were managing the whole show of hundreds of terabytes of data just with Postgres. Okay, I'm not sure if you have heard about it, but Postgres is one database which is open source and is uh, used quite often in the open source world. So we had one of the PhDs whose masters and PhD was in databases, as well as his he was a great contributor to Postgres. So we have gone through that cycle at that point of, exactly this cycle at that point of time. So we stopped doing all kinds of server side computation, and still there would be some queries that are still too slow. So what you start doing is you start periodically pre-materializing the most complex queries, and you try to stop joining in most cases. What does it mean by pre-materializing? Pre-materializing means we know that there is going to be traffic on this object very soon. So as soon as an object is modified, we again prepare everything quickly so that before the next query comes in, we have everything ready. Okay. Now, at this point of time, the reads might be okay, but while we were improving our reads, we hurt our writes. Okay, the writes as in the modification of data. The modification of data would keep on getting slower and slower. Adding a record would take some time to propagate across multiple tables. Now, what we start doing is we start dropping the secondary indexes, because what is an index? Index is exactly like what you see at the back of the book. Okay, what you call glossary. Okay, not like index in the beginning but at the back. What is that index? You take out the most important words, or most you take out all the words from a book, then you compute their frequencies and order them alphabetically and put it on the back with the position where those words were found in that book. Now, similarly, you have the database indexes, whereby index contains the location where it was found in the book, in the table, and you can quickly jump into the database does it all for you. The moment you query a table on a table, your query is based on a column which is indexed. So instead of actually looking up sequentially in the table, the database will look up in a binary search way in that index. And what is binary search way? You quickly jump backward to the middle of the book in order to. So let's imagine that you're going through the index at the back of the book, and I ask you find mango. You will first look at the end of the index. You will find that, oh, the end of index is Z. So you jump into the middle of the index and then compare the middle one with mango. If that word is smaller than mango, that means you have to search in the second half of the index, otherwise you have to search in the first half. Okay, so that's like bisection method or binary search for most of you. So when you create an index on a table, what happens is it makes the search really fast. It makes the search in a logarithmic way fast. What is logarithmic way? Instead of search, if searching for one record was taking 1 millisecond, searching in 100 records will take 2 milliseconds. This is logarithmic way of doing things. Okay, so so basically we create many indexes, sometimes on one column, sometimes on another column. Sometimes you combine the two columns and create an index, so that when people are searching on two columns, you start giving them results. Now, when the writes are slow, why are the writes slow? Because when you modify a table, there are a lot of things happen in the background. The first thing that happens is you update the indexes, meaning every time you modify the book, you have to update the index that is on the back of the book, right? Because you might have added a keyword which. So similarly, when you modify a table, the column which contains indexes, the indexes have to be updated, and all of the indexes, first, second, third, fourth, all the columns indexes need to be updated. Now, this is slow. So you try to drop the secondary indexes in order to avoid these kind of problems. Similarly, there's something called triggers on the table. Triggers is a logic which get executed when something happens on a table. Something like when the table gets new row, or a row is edited or deleted, or the the table get dropped, table get created. So all those kind of triggers cause the delay in the writes, because every time you modify a table, all of those trigger logics have to be fixed. So you start dropping secondary indexes and triggers, okay, as much as you can in order to make the writes faster. All right. So what you see right now after the step number 7, what all have we let go of? First, we don't care now about indexes, whether a database is providing us indexes or not. Secondly, we don't care about the multiple tables which is containing joins, which means we don't care about the primary foreign key anymore. We don't need it. Second, we don't need the caching. We don't need we do not provide the consistency. So what you see here is the things that defined databases are no longer material to you. The things, the features for which your you bought the database do not matter to you anymore, right? Why? Because why is it so? Because you want performance. You want the updates and the retrieval to be extremely blazingly fast to cater to your millions of users. Therefore, when at Amazon they faced the Black Friday. Black Friday is a time where there are a lot of near Christmas, where there are a lot of deals are given to the users, as well as there's a lot of traffic on Amazon because people buy a lot of gift to give to each other. So Black Friday is a test of a website, and Amazon failed at one of the Black Fridays. So at that time, one of the engineers said we would have to rethink what is the database. Why do we need database when we are not using any of these features anymore? So they came up with this simple scheme of things whereby a database was nothing but a small key value store. Database was reduced to two columns in a single table and made it such that the same table is sliced and put in onto multiple machines. So you can imagine a database to be just containing key and value. It's like a phone directory whereby first page of the phone directory is on one machine, second page of the phone directory is on second machine, and so on. And there is somebody in the middle who is keeping track of which pages are on which machine. Now, these kind of strategies made the would make the phone directory look up really fast. In the similar way, the database which Amazon came up with called Dynamo made 90% things really fast. Okay, so most of the things where there's a lot of demand of the performance moved to the NoSQL, which was Dynamo, the key value store. Okay, so we'll go into the details now as we go further. So any questions on this story? Is it clear why what does it mean by this story to you? So Satyan, is my voice clear to everyone, or am I breaking very often? Okay, looks like Satyan, it's a problem to you, problem for you because everybody is okay. All right. So, any questions? Do you have any questions on the story? This is the real story, and probably everybody faced it, and that's the reason no sequels came into play. Now, general question is, what people when people ask you that, hey, what people did before NoSQLs? People used the existing databases by themselves in a kind of NoSQL way. Like, we will convert the table into very simple structure, and we will slice the table into multiple machines. We will have like 20 databases running on the network, have 20 sections of a table spread over these databases. Then there will be another server containing our web application where our first request would go, and that request will help us route our request to these other databases. Okay, so those kind of architectures had to be done by ourselves, and that's where most of our time was going at the companies like D Shaw, because we had to handle that humongous data as humongous number of requests per second. Okay, any questions at this point of time, anyone? I know the match is going on, but I can't help. Sukhvinder's question is, but then how we handle the request, like which include multiple pages from different machines. Okay, so I will give you a quick example of how do we handle um, uh, the data which requires multiple machines. So the strategy is generally like this. So let's imagine that you are responsible for Amazon detail page. The request for this page has come here. Okay, so what we do is, for this section of the data, this section of the data, the request goes to different machines. Okay, this is another machine, and this is another machine. Okay, this is another machine. You see that? Now, once the page is finished, it goes to the user. So the request from the user comes in. Every section of the request goes to individual machine in a parallel fashion. These are this. All three requests start in parallel, so that they finish rendering each section in parallel. And that's how we do that. So we basically have around, on the detail page, I'm talking about this particular page. Okay, so let's say, all right, so let's say there is this product. Okay, so this is the product detail page. All right, so there is one server which prepares the menu. There is another server which prepares this share button here. There is one machine which gives these details. There is one machine which just gives the customer reviews. So this is comprised of many sections, and there is one machine whose duty is just to give this image. So we basically run all of these requests in parallel. So around 100 machines on an average handle a traffic on Amazon.com. Okay, sometimes it goes up. So Sukhvinder's question is, but in that case, what about the network traffic? So network traffic amongst these machines is generally considered really, really low, because most of these machines are located in the same rack. All right, makes sense to you now? All right. Sukhvinder's question is, and how does receiving end handles all the requests at the same time? So the way we do is we have these parallel threads open for each request, and all of these requests basically make a slot saying the data is coming for this slot, and there's a timeout for each slot, and every slot is being prepared by a separate machine. In case the slot is not prepared within a certain time, we expire that part and do not display that particular slot. Okay, and then we give out the results. All right, great, great, brilliant, brilliant. So yeah, so I have been lucky to be part of the team where we used these features very often. All right. Now, question is, again, let me recap by the way of this slide. Why do we need NoSQL? First, for big data. Second, for high availability. Third, for scale out architecture. All right. So first, for the big data. So these new genre of NoSQL databases provide you a way to store humongous data the way HDFS was providing you. Second, high availability, meaning in case there are many requests coming in, still you would be able to cater to them. Third, and as well, sorry, for high availability, when I mean is what I mean is in case some of the machine goes down, still you would be able to cater to the request. Third is scale out architecture. What does it mean by scale out architecture? In case today you wanted to store 1 terabyte data, tomorrow you might want to store 2 terabyte data, and day after that you might want to store 3 terabyte data. And you want to do it gradually. You don't want to do it upfront. You don't have that breather. As in when more and more drives are coming in, you want to add them gradually instead of waiting for all the hard drive to arrive and then start the server. Okay, so basically, as and when your server runs out of disk space or the machines, you buy more hardware and add to it. Just like in case your single horse could not handle the load, you add more horses. In case those horses could not handle the load, then you add more cattle to the single cart. So you can see that in this diagram, they have added all kinds of cattle into the cart. Okay, so this is scale out architecture. In commodity hardware, you did not have to add an elephant in order to pull the cart. You were able to get away with the usual commodity cattle, right? Similarly, commodity hardware means it's nothing special, but commodity hardware does not mean that it's a bad hardware. No matter what you do is in case of your server, make sure that your fan is of high quality, the databus is of high quality. Of course you will take care of the processor, ram and other things, but do not compromise on the quality of the motherboard and the other surrounding peripheral components. Okay, so it's not cheap, but it is commodity hardware. All right. Now, what is a NoSQL database? These are the few properties, and all of these properties govern from the same three ideas. These properties are the result of these three things. We want big data, as in, we want to store petabytes of data. Second, we want reliability. We want reliability and availability, meaning in case there are many concurrent users or in case there is a hardware failure, your system should survive that. Third, you want scale out architecture. Okay, scale out architecture is the solution to first two problems. Okay, solution to first two problems. kind of, because you slowly keep on adding hardware whenever you require. And the general thumb rule of adding hardware, you can make a note of it, is when your hardware is 75% consumed, you double the capacity. When your hardware is 75% consumed, you double the hardware. Does it make sense to you? Let's say you had a machine which is running on whose memory is 75% consumed, or the disk is 75% consumed. You should double the hardware immediately. And that's a thumb rule. Probably everybody who is into data center management would know this. Okay, so what exactly is NoSQL database? NoSQL database provides big data, volume, velocity, and variety kind of things to the end user. Okay, now to do that, they need to go with the distributed architecture. And when they go with distributed architecture, what does it mean by distributed architecture? The database will comprise of many machines. And when you have many machines, some records go to one machine, some record go to another, some record go to the third one, and so on. And to handle such kind of complexity, where some record is are here, some record are here, you have to have an identifier for each record, right? You have to have, like in battalions, you have to have an identifier for each person. Otherwise, you would not know where is which record, right? Therefore, you have to have an identifier for each record. So you can say that primary unique key for each table is mandatory in every NoSQL. All right. Now, NoSQL stands for not only SQL. It's non-relational. Non-relational because if you put all the relational constraints, it won't be able to provide that kind of performance. All of the distributedness will be hurt badly. I will come back to this point, that why does relational hurt our distributedness? All are open source. Why? Can anybody tell why these servers are open source? Anybody? Why these all NoSQL databases are open source? Or in other way, if today you have to develop a database, do you need to make it open source? If so, why do we need to make it open source? Yes? Sukhvinder says so that anybody can use. Okay. Vivek says so that others can contribute. Okay. And improved upon. Leela says can find different approaches. Okay. Mohammed says so that it catches up on the RDBMS. All right. Prabhund, I will answer your questions after this. Okay. More number of users and chance of getting caught by someone is quicker. Okay. Great. All right. So I'll tell you why. Because when we started T-Bits, my last company, we faced this constant challenge, because a database stores data, right? And when something stores your data, you have to have complete trust on that. In case the company who is handling this database is shut down, what happens to their data? Can they take it out? What happens in case the data is there in the database and database get corrupted? How can a company trust a new database? Specifically when they have these great solutions like Oracle and Microsoft SQL and Postgres, how can a company adopt a new database? It's a very difficult choice for a company, right? Therefore, if you want adoption, if you want your software to be adopted by many people, in case your product is uh, capturing the information of the user, then you have to make it open source. All right. Third is horizontally scalable, of course. That is the property of NoSQL, and schema free. All right. And then easy replication, simple API, and manage huge data, commodity and commodity hardware. Okay, so generally these NoSQLs are not able to provide a SQL kind of structure. Okay, all right. Now there are different kinds of classes of NoSQLs. These are the kind of vague categorization. So be with me in this. First kind of databases are Accumulo and Cassandra kind of databases, which are very similar to tabular structure. They are called column oriented and wide column. We'll come back to it why they're called so. Second is document oriented database such as ClusterPoint, Couchbase, and MongoDB. What is a document oriented database? Document oriented database is what is a document? Let's talk about what is a document. Document is a complex object. Like for example, you have to store TV shows. So the way you store is you create a kind of XML kind of a structure or JSON kind of a structure where you have TV shows. Then TV shows contain seasons. Seasons contain episodes, and episodes contain reviews and cast members. Okay, so this whole thing is created as a single object. This whole thing is created as a single object. Objects within objects within object. And that's what makes document database complex. Okay, so the good thing about the document databases are, even though each row is basically an object, row does not have the flat structure of only columns, but row has an object which contains fields, which contains fields contain another fields, and so on. All right. The third is the key value kind of a store. Okay, key value are the most basic store whereby you store the data in the form of two columns, key and the value. These are the most primitive one, and they have been upgraded such that value can be a complex object and in nowadays, which means in today's time key values have been replaced with document oriented database. But key values are something very, very important. This started as flat key and value, where key was a string, value was a string, and and later on key was a string and value was a binary data. Okay, but now they have been replaced with document oriented database. All right. Now the fourth is a very new kind of database which help you store the complex structure. Okay, the complex structure of a graph. All right. While document stores only tree structure where one object contain another object contain and so on, and key value just contain store two data in a record, while the graph databases store the complex structure of complex relationships between various objects, specifically used in the social network. Okay, so you have Allegro, Neo4j, and ObjectDB, and so on, specifically Giraffe. All right, this is a standard NoSQL versus SQL summary. That's nothing much different, so you can go through it. All right, now let me take few questions before I jump into cap theorem. Okay, all right, all right. First question from Prabhu is: can Hive query talk to NoSQL's DB? Yes. Now, next question from Prabhu is: how is data handled? Yes, and pig too. Okay, so pig also can talk to most of the NoSQLs around the world. Now, question is: how is data handled from different NoSQL DBs if relations are not defined between tables? Okay, so mostly wherever you need a relationship between table 1 and table 2, you generally merge table into a single table. Okay, so you actually, it's a very good question first, and it's quite a big question to answer. Okay, we will. This part is something called data modeling. Okay, so in case of document-oriented database, we take the benefit of complex objects, as in object containing another object. Okay, and in case of the wide column, okay, in case of wide column, we merge the various tables into a single table and so on. Okay, so we will show this part as part of today's exercise in HBase. All right, okay, all right, good questions. And all right, so let me try to answer one at a time. Now, this continuous one. So the question from Prabhu is, let me save this data. Okay, very good questions. Let me try to keep them here. Very good. Thank you, Prashant. All right. All right. Yes, Sukhvinder, that's a good point. It is regarding that open source part. All right. Good. Now, okay. So the quick answer is that we utilize the properties of the database, such as complex objects, as well as in case of wide column, um, complex objects or sub documents. Okay. In case of wide column kind of databases, we merge various tables into a single table. Now, all right. Now, the further question is, for instance, on one page is pull data. One page pulls data from multiple tables in NoSQL. How the data is mapped to display in one page. Okay. So, do you remember? Have you used an Excel sheet to maintain various kinds of data? So in Excel sheet, what we do is whatever is the instead of adding rows, sometimes we keep on adding columns, right? That's the way we basically manage this. So, for example, when you follow up a lead in a marketing department, you make an entry for the name of the lead, and then whatever follow ups are there, every time you keep on adding more and more columns against that name. So that's how we generally manage in case of wide column. Now, okay, now that's the second question. So, how can you merge tables for if every record in main table it have multiple records in the detail table, right? Very good point. So let's say in table 1, okay, you have row 1, okay, you have row 1 and all right, and data 1, row 2, okay. In table 2 we have row 1 and detail 1, row 1, detail 2. Okay, so generally the way we merge is we make it a table in say HBase. I'm just taking an example of HBase where we create row 1 and then we have first column as table 1 table 2 dot row 1 and table 2 dot row 1, or you can say dot detail 1. These are the column names. Okay, the detail itself has gone into column. Okay, you will see this in detail as we discuss further today or tomorrow whenever we get time, that how we model the relationship between pages using a single table. So note that the data has gone into column name. Okay. All right, good. So basically, it's just like if I could, I'll demonstrate you today. Okay, a question, a question from I think Vijay. Why do you think Oracle or Microsoft has never got into NoSQL DB? Just curious, is it because this is against their fundamental foundation? There could be many reasons, and there could be the reason that they are doing it internally in the organizations. Okay. I think both of them are working on NoSQL databases parallelly. All right. Next question is, can you please comment on the robustness of these stores from your experience? Okay. So, and all right, it's a very tough question. So, Mohammed, can we park this question for a little while later so that I can talk about a little more about these choices? Okay. If you are in hurry, I can suggest you a good book. Okay. All right. Because yeah. All right. Let me suggest you a link. At least I like one of the link that you can just go through. Okay. All right. Okay. So here is something which you can go through before we discuss. All right. Good. All right. So I think that's pretty much all the questions. Now there was one question. Is all NoSQL databases are considered for big data? Yes, kind of. Because most of the NoSQL are distributed, therefore they can handle the data which need a distributed computing. All right. Now, question from yes, this was Sukhvinder's question. So yes, kind of. It's not about challenging. It's about surviving against big companies like IBM. Okay. So when they have DB2, when they have, all right, when they have all these kind of databases, okay, so they if a company like MongoDB, they need to survive against them, therefore they have to make it open source so that people can take them. All right, we had a tough time selling T-bits because we were closed source. So what we had to do is we had to create this kind of a wallet where we had to write down our names saying, here is our source code. In case our company dies, then you can take the source code. Okay, so that's fine. All right, now the very important aspect which you need to understand. All right, a very important aspect, the cap theorem. So after trying hard to provide acid properties to distributed databases, few researchers realized that it's not possible. One of them was Eric Brewster. He said it through the cap theorem. What he says is that these are the three properties that none of the database can provide at the same time. First is consistency, second is availability, and third is partitioning tolerance. What does it mean? Consistency means all users or all nodes see the same data at the same time. Okay, for example, somebody who has just written data and just reading after a microsecond of writing data, they should see what they have written if somebody else has not written the data before them, right? This is consistency. Okay, it should not be that some of the people are getting some other information and some other people are getting the some other uh, version of the information. Okay, this is inconsistency. All right, now second is availability. Availability means guarantee that every request receives a response about whether it was successful or failed. More now the number of requests that can be handled by a server, more is availability. Okay, so 100% availability probably none of the database can provide logically. Okay, the third is partition tolerance. What does it mean by partition tolerance? Partition tolerance means if there is a network disconnectivity, still the system should be running completely well. If there is a disconnectivity at any point, the system should keep running without 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 giving the wrong data or without system becoming totally inconsistent. All right, now let me try to explain why this cap theorem is valid. I've thought about it again and again. I've gone through their paper multiple times to try to figure out how can I best explain cap theorem. Okay, so cap theorem, they have tried to make it too technical. I'm trying to make it really simple to understand. Okay, so I'm letting go of too much of accuracy, but this will be the best description you will get for cap theorem. All right. So why is it so that these three C, A, and P cannot be provided by a database simultaneously? Let's take a look at different cases. Okay. Let's take a look at different cases. First is, let's take a look at the first case scenario where you have this nice database, very robust one. All the users are writing to it, and all the users are writing from the same machine, reading from the same machine and writing to the same machine. That means our usual database. Okay, a single machine reading, all the users are reading from it and writing to it. Okay, now what happens when this machine goes down? What happens when this machine goes down? Reads and writes both are lost. That means it's not partition tolerant. What happens when there are many requests reading the data is no longer available because all the requests will be waiting in the queue, and after a point of time the number of requests will expire, right? Therefore the availability is really bad because it's a single system. So now let's take a look at the another diagram. The first diagram was able to provide us consistency because there was a queue, people were waiting for one to finish for another, and so on. So our usual RDBMS is great when it comes to the consistency. It has transactions. Transactions have all ACID properties. It has primary and foreign key relationships and whatnot. So it is great at providing you consistencies. And if in production you need consistency, then stick to the data RDBMS. Do not go with NoSQL. All right. Now let's take a look at the second diagram. Okay, in second diagram, people are writing to A and reading from B. Although some people would be reading from A as well, therefore, people who are reading from A and people who are reading from B will see data at different point of time. Why? Because there will be some time lag between data reaching from A to B, because users write to A, then the data goes from A to B, or if there are more servers like B, like C or D, then the data goes to B and C, and then users read from A, B and C, and so on. That means that if there's a network lag, B might see the data really, really old, but data will not get corrupted. Inconsistent does not mean corrupted because it is eventually consistent. Okay, it's not inconsistent, it is eventually consistent. We know that after a point of time, everything is going to be okay. All right, because we have only one machine accepting writes. So this system is not consistent but eventually consistent, but it's available and partition tolerant. Why is it partition tolerant? In case the disconnectivity happens between A and B, okay, for some time A and B can cater to read requests. All right, and in this diagram, if there is a disconnectivity between A and B, A will stop receiving right sorry, B will not receive write request, but A will receive. And if the connectivity comes back again, A will transmit all the changes it has received after the disconnectivity. All right, so that means the things are eventually consistent as well as partition tolerant. Partition tolerant, if the connectivity between a writer and A goes down, then the writer may not be able to write, but reader will continue to read. So this system is great. It's consistent. It's eventually consistent, not consistent, but available and partition tolerant. Okay, in case machine A goes down, still you have some breather. B goes down, you have both reader and writer available. By the time and uh, by the time A fails, you would be able to set up some backup. Okay, now the third diagram. Okay, so the third diagram is interesting. There is one front which is accepting reads and writes, and there is a backup. And where did you see this kind of structure? Anybody? That like third one, where did you see this third one? We have seen it already. Correct. We have seen it in high availability in HDFS, primary and the backup name node. Okay, so A was a name node and B was a backup name node. Now, so what happens in this kind of scenario is the in case A goes down, you have B who can serve in place of A. And as soon as A goes down, B takes the place of A. At least you have the partition tolerance. But again, A suffers from the similar availability as compared to this node in the first diagram. Therefore, it is consistent, it is partition tolerant, but it is not available. So here in this diagram, okay, in this diagram, there are three servers which fall into. One, HBase, other HDFS, and other RDBMS with a backup. Of course, the availability of HBase is far higher than any other databases. We will come back to this again. All right. Here, this kind of diagram is there in MongoDB and Zookeeper. We will study Zookeeper so you will understand how does the system work, and we have studied the HDFS backup system, so you know what happens there. And we will also study the HBase so that you will understand the second. So second and third diagram we are going to discuss as we proceed further. And the first diagram is basically an RDBMS kind of a system. All right, let me see your questions first. Okay, a question from Prabhund is, can HBase component library be installed on all nodes in the cluster? How it is usually set up? Okay, if HBase, so the way we do it generally is we do it through a component like Puppet or Chef. There are these systems like Puppet and Chef. They will, okay, Ouch, I think I've minimized. Okay, good. So, all right. Okay, Prabhu's question is how are other NoSQL DBs like Cassandra and MongoDB configured to work with Hadoop? Yes, that can be done. So you would like to look at one of my videos called Mongo Hadoop. Okay, Mongo Hadoop. Okay, that should give you idea. You look at our channel and that will give you the clarity. And so another question you were asking, let me write it down. Okay. You generally have Puppet or Chef. Okay. Next, Vijay is saying, are there no repercussions for showing old data on B? Yes, there are. Okay, this let me answer in detail. So here, basically the data is little old. And in case your system require does not tolerate this kind of model, then you will have to either shift to another database or you have to find other ways. Okay, let me check Sukhvinder's question. Okay, good, good. Sukhvinder, yes, HDFS was the answer for the question regarding the third diagram. All right, great. So I hope the cap theorem is clear to you. Now you can see that if you think about other kind of configurations, you'll find that one or the another, at least one of CAP would be not possible. Okay? Alright. Now let's move to the last one. Sukhinder is saying, isn't possible that when we write to both databases at the same time, okay? Sukhvinder's question is a writer should be able to write to A and B at the same time. Okay, so that means the writes are going to be slow, really slow, and A and B would be two disconnected islands where everyone is writing to. Okay, and again, if you have more than secondary systems, okay, more than B secondary systems, what would happen is that then you'll have to write to A, B, C, D, E. Okay, so instead, the standard technique is you write to A so that if this goes successful, A takes that load of writing to everyone, and all of these machines keep on getting the updates. All right. So what happens is in most of the databases like Zookeeper and all, you have A, user writes to A, then A's data get copied to B. Now, if there are C and D, then the data A, uh, the load of copying the data will be shared by A and B both. That happens in case of Zookeeper. So it's far more clever than the way we are thinking. So basically, when the way if you're downloading a movie, the more the seeds you have, the more the supplier of the data will be there, and hence the data up the movie download will be faster. Similarly, when you're writing to A becomes the producer of the data, then A makes B as well the producer of the data, and then both of them will write to other servers. Okay, I hope you got it. So yes, thank you, Sukhvinder. Great questions. I mean, I'm really happy that the kind of questions I'm getting in this class are just wonderful. All right, now, okay, let me just move. All right, the one another idea that might you might find a little strange, and these ideas are something which are important to learn. The ideas, the ideas beneath the skin of a database, NoSQL data store. Okay, these are those ideas. Starting with the cap theorem and starting with the horizontal scaling. Now, this is the third idea that we need to understand. The column orientedness. What does it mean by column orientedness? For the end user, it doesn't make much of a difference. But for a developer or for a product developer, it matters a lot. When you are given a CSV data, or when we are given a data which contains rows and columns, and we have to store it somewhere. There are two ways there are multiple ways to store it. One, you first store the you first store each row into the file. Okay, you first store the first row, then second row, then third row. The second way could have been that physically you store first column first, second column afterwards, and third column. For example, you see that in the first approach, row oriented way, this is the traditional approach, the way we are storing in the file. This table is being converted into file, and the way we are saving it is in the first row we are storing 10 Joe. Second row, we are storing 12 Mary. Third row, we are storing 11 Kathy. This is row-oriented way of storing in the file. The second way is you first store the first column. That means you store 10, 12, 11, 10, 12, 11. Then you store Joe, Mary, Kathy. Joe, Mary, Kathy in the file, right? This could be another way of storing. While the first one is called row-oriented databases, and second one is called the column-oriented databases. Why is it useful, and why is it make sense to have column-oriented database? So few researchers found that if you compress the data, if you put the data together from each column and then you try to compress, each column is far more smaller as compared to the row wise. If you try to compress this data first and then this data, it will be far more smaller as compared to you try to compress the first row and second row. Why is it that if you try to compress this together and this together, it is smaller? Why is it so? First, if you have similar data, that it is going to be easier to store it. It will be easier to find the similarities and replace those similar data with a smaller symbol. For example, you are storing in this column the sare gamma pa. Okay, this column contains the key notes, the musical notes of a music, right? That means the column will contain sare gamma pa or something like that. And when you take out sare gamma pa, you could generally replace sa with a symbol, re with some other symbol, and so on. And effectively, you'll be able to compress it to a very high level. All right. And in the second column, let's imagine that you have DNAs, and And when you have similarities in the data, say male female and so on, you will be easily able to eliminate the similarities with a symbol. Okay, so the compression, the compactness will be higher in case of column oriented data data. All right. Okay, is the idea about column oriented, row oriented clear to everyone? No. Okay, so let me try to ask you another question. Okay, I think that will make you clear about it. All right, let's take in a case of say you have this table, right? This is a nice table. Now the way you store it in file, let's say this is a fresh file you are creating, and you store 10, 12, and 11. Of course there is a separator. Okay, and then you store Joe, Mary, Kathy. Okay, so when you compress this data, okay, will it be smaller? And you compress this data together? Or imagine that you have a column called age, right? And age goes from 0 to 100. Okay, and while compression, these techniques figure that out, that this number is just varying from 0 to 100. So instead of, so they will give a, create a byte vector and make it really small. So in order to have a great compactness, we prefer to store the data in a column wise fashion. Does it make sense to you, Sukhvinder and Prabhu and Anand, Ashok, Anyan, Lakshmi, Leela, Muhammad, Rajiv and Sundar, Suraj and Thiru, Vijay, Vivek? Good, Muhammad. All right, great, great. So, all right. Now, so there was always this tussle going on that, all right. So Ashok's question is, so the data type of the column is playing important role. Kind of, yes. And l- if the compression is right, then even if you do not specify the data type, the compression will automatically make the data compact by understanding the data itself. Okay? Anian is saying this is only done for compression. Yes. Okay. Great to know, Leela, that part. Vivek is saying, is compactness the only advantage? Moreover, we have huge storage capacity these days and cheaper as well. Does it really matter? It kind of matters for most of the storage engineers. And so sometimes you want to retain some part of it in the memory and so on. All right. Okay. That was exactly my thought as well, Vivek. But yeah, those I mean for the scenarios where data is really humongous and you don't need it so frequently to uncompress it, people generally like to keep the data in compressed format. Now there was already this tussle going on that let's store the data in row oriented. Other said, no, no, let's store in column oriented. Because if you store something in row oriented fashion and you want the column together while retrieving, then it doesn't make sense. Sometimes you want all of the data of the row together mostly. For example, when you are retrieving customers information, you would want first name and last name always. Okay, mostly, almost always. And but you may not want their personal address along with their official address. So there was always this tussle going on whether to keep the database data row oriented or column oriented. The clever trick which HBase did, okay, so what did HBase do? HBase planned for a column family oriented database. What does it mean? What does it mean? That columns are grouped together into column families, and the data in the column families is stored together. Okay, data in column families are stored together. For example, employee ID and name will first get stored, and then the second column is so. I'll show you what exactly it means. So the data in different column families is stored together. So first it will store column family 1, then column family 2. Okay, it will store the data in column family first and then data in column family 2. But inside a column family, the data gets stored row wise. Okay, so data gets stored row wise. All right, I'll try to show you what do I mean. Okay, so first this, sorry, and first this, then kind of this, then kind of this, and then this. Okay, so you can see that. All right, so you can see. Okay, so this is something stored first, and then stored second, then stored 1.1, then basically this gets stored first, second, third, and fourth. All right, so this gets stored first, second, and third, and then fourth. Okay, so basically data in a column family is stored together. Okay, and within a column family the data is stored in a row wise fashion. Now NN is saying is in row oriented, numbers like 001, 002 come first, and a column oriented number comes second. And no, not much of a significance. It just signifies that we want to store the row number as well. Okay, all right, good, good. All right. Now, why, when I said why is this column family oriented? Okay, a very clever choice. You see, here there are three column families, and here there are there is a single column family. What do you think this is? Is it the first one is a column oriented way, or or the second one is a column oriented way? Which one is row oriented? This one is row oriented, or this one? Correct, Leela. Good, very good. So what you see here is something wonderful, because unless I went to this detail, I did not realize what's the benefit of this column family oriented thing. The reason was it was politically very correct decision, or architecturally it's a correct decision. You can see that if you want explicitly that I want column oriented database, then you make one one column per column family. If you want your database to be stored as row oriented, put all the columns in a single column family. Okay, this makes sense to you? All right. Prashant's question is there a max number of columns that can be accommodated in column family? No. There is no upper limit. As long as it can be stored, it will be stored. All right. So that was about the concepts behind NoSQL and HBase. Now we will move on to the next stage, understanding HBase. All right. Right. Let's take a break for 10 minutes. Back by 10:20 p.m. IST. All right, so can we start now? All right, so Sukhvinder is back, so let's start. All right, so in the first half, we discussed about NoSQL and the general ideas and the concepts behind a NoSQL. Okay, the ideas which are needed to understand the concept, the databases which are of type NoSQL. All right, so all right, so what exactly is HBase? HBase is a NoSQL database which is column family oriented and provides you C and P out of CAP, meaning it is able to provide consistency and partition tolerance but not much of an availability. Not availability as in not too much of availability. The TPS is quite high as in the transaction per second is quite high in HBase, but again, it's not very good at availability. Okay, so C and P again, HBase was created by by following Google's Big Table paper. So, out of the three papers published by Google, the third paper about Google's Big Table was a basis for HBase creation. It's good for hundreds of millions or billions of rows. If you're not expecting millions of rows, you stick to your classic database. If you are expecting the rows more than a million, only then you use HBase. Okay. Otherwise, you may not find it too much of a use. All right. Now it's strongly consistent. It basically it's not eventually consistent, it is strongly consistent. Okay, it provides automatic sharding, as in dividing the data amongst multiple servers by the way of region servers, and it provides automatic failover in case one region server fails, other takes over. All right, and it provides a good Hadoop HDFS integration, and it is massively parallelized processing using it provides MapReduce processing via MapReduce. Okay, it provides various kinds of APIs in Thrift and Java, and since it has Thrift, that means almost every language is supported. And the API is very basic, like get and put. Okay, it provides two more features called coprocessors and Bloom filter, which we will discuss in detail. All right. Now let's go through the basic architecture of HBase. HBase has one master and others are region servers. Just like name node and data nodes, we have master and region servers. Master contains information about what is stored in which region server, and region servers store the actual data. So imagine that there is a very huge table. It is cut into portions and put on many region servers, and then master is keeping track of from what page number to what page number, or from which word to which word is stored in which region server. If you have used Oxford dictionary, on the dictionary you have at the top of the page the range of words, right? From this word to this word is what is contained on a page. Now imagine that you basically break the dictionary into page by page. You put one page on one machine, another page on another machine, and You make a central record of the top of the page saying from this range to this range was on this page and so on. And then you can quickly, whenever people are asking for a particular word, you can quickly talk to that particular region server containing those pages. Okay, and the region server, how do they store the data? They store the data on HDFS. Okay, region servers store the data into HDFS. They don't store the data into the physical file system. Instead they store, because each region server is supposed to store a portion of a big table. Okay, and region servers store the data in HDFS, which means that every portion has got three copies. In case one region server is down, then you have another region server which would be having the access to the same data. All right, so also the coordination between master and region server is done through zookeeper. Okay, so instead of master keep taking the attendance all the time from region servers that hey, who all is up, like the way I'm doing continuously, that hey, are you there, are you there, can I start now? So similar to that, instead of doing that, there is another guy called zookeeper who is keeping track of which region server is up. That makes master free from the taking attendance from all. Yes, kind of. Prabhu's question is, can we say one region server is one data node? Kind of, you can say that. Okay. All right. So this way, while master is redirecting the users to store the data in region servers converting the data into the actual file and putting that file into HDFS. Okay. And these region servers are coordinating amongst themselves as well as with the master using the zookeeper. So zookeeper, instead of asking every region server, where are you up or down, or are you up, and give the attendance, zookeeper is taking the attendance, and master is asking the zookeeper that who all are available right now. Okay, so we'll go into the details of zookeeper after some time. Prabhu's question is, usually HBase master server is on the name node or on data node. It can be on anywhere. Okay, you generally keep the HBase master somewhere where the memory is free. It need not to be on the name node. Okay, it need not to be on the name node. So Ashok's question is, so the zookeeper is the main guy with whom the master is always talking. Yes. So zookeeper is just giving the attendance. Okay. It's like having a teacher, one more secretary who keeps on tracking that which are the students are awake right now. In case somebody is sleeping, the teacher does not wake them up and ask them a question. Okay. Similarly, the master keep on asking zookeeper that which all nodes are available right now. If it is available, then it will talk to them directly. All right. Otherwise, plan for keeping the backup somewhere. All right. All right. Now, question from Prabhu is, can you explain MAM store? And well, let me take this up at later point of time. All right. Not now. Yes. So Quinta, the zookeeper is just kind of a clerk. All right. Now let let's understand few of the dynamics. Okay. So let's understand what does it mean by a reason. So HBase stores data into tables. Tables are automatically partitioned into regions. Horizontally they are cut. Okay, they are horizontally cut into regions. Initially, when you store data, the data is going to be stored in the region. Master is just keeping the record of from which row range to which row range has gone to which region server. Okay, so a table is divided into regions. Initially, when you start creating a table, it contains only one region. It contains only one region, and then as you keep adding more and more rows to this region, the region will the table will keep on increasing, and when it reaches certain threshold, it will be cut into two half, exactly two half, and moved to different region servers. Okay, so after a point of time, when and then you then these reasons, these two reasons which have been created out of a single table will keep on expanding independently and then keep on dividing again and again by itself. Okay, so the architecture of reason splitting is just like B tree. Okay, don't mind if you don't have read B trees. So the idea is that you have a big table and then it is cut into two halves, then each of them keep on increasing, the reasons independently keep on increasing. As soon as these reasons will further split into sub reasons and so on. Okay, so all right, it's it's like a small tree. As they become bigger, they become two branch, and each branch, when they become bigger individually, they keep on splitting up further and further. So as and when the data is growing, more regions are being created, and the they are moved to different region servers. Okay, and the definition. All right, a question from Ashok is that does the reason split based on number of rows or the size of the reason? It is the size of the reason, not number of rows. Size in the terms of the whether it's uh, you can predefine it. All right, so each region comprises of a subset of table rows, and a reason, basically what would define a reason in HBase. Okay, an important thing to understand in case of HBase table, this table contains one row, as we told you earlier, that every NoSQL has one column which has the ID. Similarly, HBase contains one column which is row ID, and this row ID is mandatory in the HBase table. The columns or other values in this table are optional, but every row must have an ID. And the way HBase stores the data, it is ordered by the row ID. It is ordered by the row ID. So each region will also contains the row ID, okay, or row key in the ordered fashion. Okay, when you have something ordered fashion, you can always say that from this node to this node, from this word to this word has gone into first region, from this word to this word has gone into second region, and so on. And this is possible only because the the data in a table is ordered by row key. Okay, the row key. So exactly the way each page in Oxford Dictionary contains the range, as in from this word to this word, that denote that okay, this page is from this word to this word. Similarly, a reason is denoted by the table it belongs to, and the first row inclusive, and first row key inclusive, and last row key exclusive, meaning if it says 1 to 10, that means on the reason it will contain only up to 9, not 10. Okay, all right. Now if this is the table that contains all the row keys, some of the row keys would be in one region, some of the row keys will be on another region, some of the row keys in the second region, and two regions could be on one region servers. For example, this region and this region are on the same server, these two are on same server, these two are on same server. Okay, so this is kind of a layout of region servers. Now, the most important part to learn about HBase is data model. Okay, before I move to data model, can I let me just take a look at your questions. All right, a question from Prabhu is okay, and a question is, can we say Zookeeper is for overall Hadoop cluster? And that's true. Yes, good point, Prabhu. Okay, and an HBase master is just for HBase. That's correct. So Zookeeper is basically a kind of a tool which you can use in your own services as well whenever you want to keep track of all the users or you need coordination between multiple servers. Okay, I think this has been answered. Great. Let's move on. All right. The data model is something which we need to understand clearly. Okay, because that's what is going to be a problem when we understand, when we try to store data, what exactly is data model. Okay, so you have a certain data, certain requirement, certain expectations from a certain requirement with respect to the user, that people want to fetch this data first, then and so on. There's certain usage pattern from the user. Okay, and on one hand you have the usage requirement, on other hand you have the limitations and the features of the database. Now you as an architect or a developer or or system engineer, you have to figure it out, you have to translate your requirement in order to fit to the features and in order to avoid the limitations of the database. So so it's very important to understand the of data model provided by the database so that you can fit it accordingly. Okay, so the most concise definition of data model in case of HBase is that is given by the father of the people who wrote the main paper on big table, because big table is the kind of inspiration for HBase. So the paper by Jeff Dean and Gamawat and one more person says that the big table is sparse, distributed, persistent, multi-dimensional sorted map. This is a very, very important definition because I can't take a single word out of it. It's just crisp. Whatever word I could remove from it, I have removed that. And this definition is probably the most crisp, and not a single thing is wrong. Okay, so let's take a case of a map. So big table is a map. Map means it is a key and value, meaning it has got row key and it has got value. Multidimensional means the value contains more fields. It's not a single value, it contains more cells. Okay, sorted means the keys in this map are ordered, which means if you can reach to first key and then you try to access the second key will be bigger than the first one, and so on. Now your question would be that if the key can be a string, then how do you order it? It's very simple. The data is basically converted into binary, and binary data can be ordered based on zero ones. Okay, now it is persistent, meaning it's not only in the memory but it is kept on the disk. Next, it is distributed. So this hash map is on not on one computer but on many computer, distributed to multiple computers. Okay, next is sparse, means the dimensions, the parts, the attributes of values can be anything. If first value contains three columns, second might contain some other three columns, or it might contain the same three column values as the first one, right? Meaning the column would, if you try to make it like a table, most of the values would look empty to you. Okay, that something would give uneasiness to anybody from the databases background. The whole table would be hardly 1% filled. 99% of the table would be sparse. Okay, and that's very much true for storing the semi-structured, unstructured, or any kind of data that into a table. Okay, so the table can be this sparse. You can store as many columns as you want, as many new columns as you want in each row can have different set of columns and the table will be perfectly working fine. Okay, unlike our databases. Okay, so this is very important definition, and if you have a question you can ask now. Yes. All right, so a table, HBase organizes data into table. Table names are string that are safe for file system path. These are few important things. When you're creating a table in HBase, make sure the name of the table is clean, with which a file can be created, because region server is going to create a folder. A folder is going to be created with the same table name in the HDFS. Row table contains rows, okay, and rows are identified by row key. Row key do not have to have any data type. They can be a binary data. You'll be amazed at the fact that row key can be the full movie. Okay, I've stored like 20 MB data in row key earlier at one point of time, and it is just perfectly fine to have any data in the row key. All right, so the row ID itself could be a good data storage. Next, column family. While defining a table, the only thing we have to define is what is the name of the table and what are the column families it would contain. That's it. There is no data type of the column family, only the name you have to provide, because the data is in HBase table is grouped by column families. So table have rows, rows have row keys can contain binary data, table names have to be file system safe. Similarly, column family, okay, so so table have column families that you defined up front, and inside column family you can keep on adding as many columns as you want and whenever you want. You don't need to define any columns at the time of table creation. Okay, so column family impacts the physical arrangement of the data such that data within a row is so data within a column family will get stored together. So you need to define them upfront and not easily modifiable. But luckily, Hue provides you a way to create column family at later point of time. Even programmatically, you can do that, but it's not very efficient process. Okay, every row in a table has the same column families. Okay, but that does not mean that all the column families need to have any column. All the column families can stay empty for a basically when we are creating a row, we can just create a row with a row key and not put any data in it. A row need not to store data in all its column family. Since HDFS will be creating a folder, sorry, uh, HBase will be asking HDFS to create folder with the name with column family under the table name under inside the region. Therefore, the name of the column family has to be file system safe. Column qualifier or column data within column family is addressed by column qualifier. All right. So data within a column family is addressed by column qualifier, or you can say column name. And also, you don't need to define the column name upfront. Column name need not to be consistent between the rows, meaning one row can have some columns, other row can have some different columns or same columns. It doesn't matter. This is something which will take time for you to gel. And like row keys, column name itself can be a binary data. That is something very interesting which I found. Okay, so when I was designing the database, I was amazed to find that I can store a lot of data in the column name itself. And we utilized it. We utilized the name of the column as the storage of the data. So we kept on adding more and more columns, and column name itself was containing data, and our cell was containing just a very small rudimentary yes or no or one or two, while the column name was containing the whole movie. Okay, so that's a very important part. So row key can have binary data, column name can have binary data. So column name and row key behave exactly same way. Okay, all right. So a cell is defined by table name, row key, column family, column name, and the version. Version is something you need to understand. Every cell has got a version. Okay, so you have row, you have column family, column name, and inside column for each row, for given a row and a column family, there is a cell. Okay, and cell has multiple versions. Okay, when you change the value of a cell, the older value get pushed to the older version, and the newer value takes the place. By default, there are three old versions kept, two old versions and the one current version kept. in HBase. You can change it at change it for every row. All right. So values within a cell are versioned. Version number, which is by default the timestamp, it's if it's not specified, when you don't specify a version that hey this is the version number, if you don't specify for each cell, then by default the current time is used as the version, and while retrieving the latest version based on the timestamp is taken if you don't specify the version number. Okay, the number of versions retained by HBase is configured for each column family. The number of versions retained by HBase is configured for each column family. The default number of cell version is 3. Alright, so you can see that here there is this table, nice table. It has got row key which are ordered, you can see that, and it has got two column family. One column family is called personal and other column family is called office, and inside personal column family you have name, other you have residence phone. Okay, and in office column family you have phone and address. Please keep a note that two different column family can have column qualifier as the same. It could have been phone instead of region phone. It is completely okay. All right, so each cell, you see the cell here, that's the actual value here, and this cell is basically having three different versions. All right, in other way you have the row key. Row key has different column families, and column families have different columns, and different columns has different timestamps and their cell values. Okay, this is another way of look at the structure of HBase table. Ashok's question is, key is unique as well. Yes, so row keys are assigned Row keys are assigned based on how data is split into the region. No, you specify the row keys. Okay, row keys govern the ordering of the data, and hence which data goes into which region is governed by row key. Okay, good question, Prashant. Prabhu's question is, can a row key be auto-generated while inputting loading data? So HBase leaves that to you. You can, okay, okay, okay. So no, HBase does not do it, but HBase leaves that to you, and you can create a unique row key based on any parameter. Or you can create a mid-layer API that will do it for you. Okay, a question from Prabhu is, can a cell value be a picture or a video within a column family? Yes. Cell value is also a byte array or binary data. Very good question. Prabhu's question is, unlike RDBMS, can we save unstructured or semi-structured data into cell value? Yes. Brilliant questions. All right, great. Sukhvinder has got the answer. All right, let me just still put the question here. Okay. A question from Vivek is, for different rows of the same column, column names can be different. Can you explain that? All right. So let me explain it by using a spreadsheet. Okay, you can see that here. Okay, so let's say the first column here shows the some column names. These are in the first column, let's say name, age, and so on. Okay, and let me just put a row key here. This is row key. Okay, and let's say there is the first row key, or let me just make the row key as email ID. Okay, for this row key there will be some name and some age. For another row key, you may decide not to put anything here, but you may decide to add called one more column called let's say ma. Okay, so it could have only, let's say, name, let's say Vivek, and marks. Okay, so this is kind of what do you say, empty. Okay, these are kind of empty. Similarly, there could be another ID which can say, I don't care about any of these fields. I want to create my own field called full name. Okay, and they can say Prasant. Okay, T. You can see that this one had chosen to keep not like this. Okay, this one has chosen to skip all these columns. That means these are also going to be black. All right, does it make sense to you? Brilliant question. All right, a question from Suraj is, does the storing of the data in column families affect how data is stored physically? If yes, how? Okay, so basically data in the same column family would be stored together physically. Okay, while storing data in, so first the first column family gets stored, second the second column family will get stored, and so on. I'll show you the right example. Okay, actually first column family will have a different HDFS file altogether. Okay, I'll show you an example of the table. After we create a file in HDFS and we add some data to it, the way it structures data is very interesting. Okay, where is the, okay, so you can see that for every table, it's going to create this kind of a folder structure. First, at the top level, this folder will be created. For every table, there will be a folder created in this folder, and the folder name is going to be table name. Inside this, it auto generates the reason ID, and that reason ID will be another folder, and afterwards there will be column family. This column family will contain the actual file, while this column family basically will have separate file, and there will be another column family. That means two column families will have two separate store files. All right. A question from Vivek. How do we decide on column families? Okay, based on based on access pattern. If you know If you know that columns these two columns are going to be accessed together, that means you put them in the same column family. If you know that they are going to be accessed differently, you put them in different column family. Prabhu's next question is, in one of the slides you mentioned that adding modifying column family is hard. Is it advisable to do it? It's not greatly advisable to do it. Okay, but it's I think the performance is not too much impacted as hypothesized. It's okay to create the column families or later on, but not too many common column families at later point of time. Yes, in the exceptional cases you can always restructure the column families by creating a fresh new table, moving the data. Okay. A question from Prasant is, my understanding that it is difficult to add new column families after, but it is possible to add new column. Yes, that's correct. Okay. It's just adding new column families takes a bit of more time. A question from Suraj is, can one column be part of more than one column families? So it's not like if we added a column to both, we don't, it'll be like two separate columns. Okay, it'll be two separate columns, so it won't be like we can make a soft link or hard link. If we change one column, the data reflects in another. That's not possible. Okay, but yes, you two column families can have the same name for the column. Yes, Vivek's question is, so it is okay to add a new column family to column to existing column family, of course. So the idea is, adding a row and adding a column is a similar process. It's a similar process. While columns are grouped into column family, rows are grouped into regions. Okay, that means the data is divided like a chocolate. It has got vertical slices, horizontal slices. Okay, all right, brilliant questions. Now let's take a very good example. Okay, let's take a very good example. Prabhu, this slide will make it clear to you. Okay, so there's no file extension actually, Prabhu. All right, this slide will make it clear to you, don't worry. Okay, let's take an example of the way the main reason why the main reason why big table at Google was invented was this. They wanted to store the the whole world's data in a structured format or semi-structured format. So instead of just dumping it into HDFS, they wanted to do a different kind of analysis over the data. Okay, and they needed it, and the way they stored was very interesting. For every new page they encounter, they create every new domain they encounter, they create one row in this table. Okay, where the row key is basically the domain name, the URL. URL goes into the row key, and there are two column families. One is called contents, other is called anchors. As in when they encounter a new URL, they create a row here, and after downloading its data from that page, from that URL, they add the data into the contents column family. Okay, as we told you, the column name could be anything, it could be even empty. So this first column is an empty column inside a column family called contents. So this table has got two column families, contents and anchor. All right, and the row key is based on the URL, and contents contain the first column, which is blank, that contains the default HTML. There could be another column called PDF. If a web page is in the form of PDF, you could have a separate column. Next is the anchors. As and when you encounter that a page is being referenced by another page, you add a column inside anchor column family. For example, CNN.com is pointing to, having a reference to, okay, sorry, www.cnn.com is referring to cnnsi.com by the name CNN. The label on the link is CNN. Similarly, this page is pointing to mylook.ca with the name cnn.com. If this page had links to 500 links, 500 URLs, there will be 500 columns under anchor column family. Okay, so you can see that the important part to understand here is you can add as many columns as you want. So effectively, this table will contain as many columns as it would contain the rows, because for every new URL, there is a reference links. Okay. So horizontally, we are adding more and more columns for each reference which is found. So first we download data, then you understand what is there inside the HTML. The raw data is stored under content, and after we understood the links references, we add columns into this table, saying anchor column contains these details. Okay, that means we always know who are referring to a website. Okay, now, so you can see that now one more aspect is that this row key is a reverse URL. Why reverse? So that Microsoft.com or email.microsoft.com or www.microsoft.com and say msdn.microsoft.com, if you sort them just like this, what would happen is they will be there will be other website that will come in between them. But because Microsoft.com is the suffix to the rest of it, therefore if you sort it, it will be the sorting will be based on the subdomain, right? That means google.com would be somewhere in between, which means if you want to get all the data related to Microsoft.com from this table, it will be difficult. Therefore, what they did was they stored the domain name in a reverse order, saying com.microsoft.email. Okay, similarly here com.cnn.www. So if they had cnn.com, google.com and www.cnn.com, google.com could have come in the midway because the data is ordered by row key, right? So that all the row key belonging to cnn.com come together, the row key has been inversed. Instead of saying cnn.com, they're storing it com.cnn. So all the subdomain for cnn.com would come together, so that if you get the first key, you'll be able to scroll down, you will able to go through the next rows instead of again searching. Therefore you have to use all these information about the data model in order to exploit every feature. Okay, so one to many relationship is created by adding more and more columns. All right. And the data which you need to gather is either in the same column family as well as it is basically having the row key such that the data comes together if sorted by row key. All right. So you can see all, and also the text, it contains the timestamp. All right. Is this data model clear? Now, a question from Prabhu was, can you explain the storage structure one more time? Okay, I'll explain to you here. Physically, when you create a table in HBase, and we will go into this folder. Let me just go into this folder. Okay. So what is that? All right. Let me just copy paste. All right. Let's take a look at this. This is a table with the name Deepti table. Under this, you see there is a big number. That means it has got only one reason. This is a reason. Okay, this is a reason ID for this table called Deepti table. Under the reason, you have these two basically, finance and HR. Okay, your finance and HR, two column families. Okay, there is nothing inside HR, and there is something inside, sorry, there is nothing inside finance, but there is something inside HR. So HR is a column family, this is the reason ID, this is the table name, and this is the common folder where every table is being stored. Okay, so you can see clearly that for this table there will be a table called in this we'll go through the table. Let me just open HBase. Okay, so inside here there is a deep table. It contains HR, and there is a name here. You can see that. A question from Prabhu is, can we say that one table for entire application? Yes, that's true. And generally, in case you see anywhere, okay. So Prabhu is saying, when I try to add new data to the table I created, I'm getting error. Can you try adding from the UI? You can add data from UI. You can see there are finance and HR, but there is nothing under finance column so far, column family so far. Okay. All right. Surya's point is this structure looks similar to old hierarchical databases. So it's not basically, this structure has nothing to do with you. I'm just getting under the skin of the database and trying to show you how physically the data is being stored. This is the physical storage of the data, as if I'm getting into data files of Microsoft SQL. Okay. All right. So let me just go back to the HBase. Okay, there is no data to be displayed or no data to display. Demography. All right. So let me try to add it later on. Okay, Prabhu. Let me take a look at it. Let's find the time. Would there would be some way to store the data? How do you add data from the UI? I know how to add it from the physical this thing. I see. I see. All right. We'll try to add the data later. Oh, there is here. Oh, it's in capitals. See, it got added, Prabhu. I'm trying to add in your data. All right. Good. So this is a simple table which we have created. Now you can take a look at the same thing under your file browser. Okay, you can see not this one. You can say PV. Okay, you can say usage, and the data has not reached yet. It will take some time because it is still temporarily written in this here. You can see this is a temporary data. It will take some time to get moved to the right column. Okay, so that explains how HBase is storing data underneath. Okay, all right. Okay, so again, let me recap whatever we have understood so far. And okay, let me recap whatever we have understood so far. Indexing is based on row key. Tables are stored based on, tables are sorted based on row key. Each reason is, each reason of the table has row key and row key, I mean, each reason of the table has sorted row key. Okay, and it is basically, reason is described by starting and ending key. Everything in HBase table is stored as byte array. Atomicity is guaranteed not at a row level. Sorry, atomicity is only at the row level, meaning all the changes to a row can reflect in a single shot. There is no multi-row transaction. Also, column families have to be defined upfront. Column qualifier or the column names are dynamic and can be added at the right time. and they are stored as binary data. So column name and sorry, the table name and the column family name are something that need to be clean because there is going to be a file with that name. There has to be a folder with that name. All right. So those are the design guidelines. All right, let's try to access HBase. Although from here you can go here in HBase and edit the table the right way. You can create a table and add the data. I'm sure all of you will be able to do it. Let me try to show you. Let me try to show you how would you do it from the command line. Okay. All right. Prabhu is saying, is reason chosen by Hadoop by default? Yes. Can we mention to which region can data be saved? No. You have no control over which region the data goes. The only control you have is choosing a row key. All right, let me open the web console, copy the data, paste the data, and copy to clipboard, paste. All right, here you can say hbase shell, all in small. Okay, and basically you can execute these commands. All right, you can execute these commands. Let's just check the status first. It says 2 servers and 2 are dead. I'm not sure if it's working or not. Okay, this is something, I think it's already working. It's unnecessary, it's showing the dead. And let's try to create mycf6 fab. Okay, so we'll say, instead of saying mycf, we'll say mycf dot 6 fab. Okay, so that we have. Okay, so let's create a table called my table. It says the table already exists. Okay, so we can say delete table mycf6 fab. You have to put it in single quote. What's happening with this? Wrong number of argument. Does it require saying table? Oh, it's my table, sorry. Okay, so yeah, that was the problem. So instead of changing the name of the column family, we were changing the name of the table, we are changing the column family. So let me try to do it. So the table has been created. Create my table 6 fab. All right, I'll paste the script here. Thank you, Leela, for reminding that. All right, I've responded to Leela's question. I hope you all got it. Yeah, thank you, Vinyan. Thank you, Vivek and Enyan. All right, so here we go. So we have just created my table 6 fab, and we can just check if it has been created or not. You can see all the tables are listed here. You could also say things like my table dot star and put it in single quotes. You can see that my table 6 fab and all. We can say scan my table 6 fab and it is showing 0 rows. Okay, now we can add. What is important to you is that it's basically treating everything like a key value. I'm saying put into this table this particular row with this particular column and a value. Okay, so I'm adding one row 2 here and one row 1 here with different column, and you can see what does it mean. Okay, all right, you can see that the table is enabled and all of the details about the table. Now before deleting a table you have to disable a table and then delete a table. Okay, right now I'm not going to disable it. Okay, so I'm going to enable the table again. So the way it works is you have to disable the table so that all the transactions should finish and then you can gracefully drop the table. Alright, brilliant. Now moving on to the next point. So physical store we have discussed, locking which we have discussed. Okay, so HBase provides you the scanners. Okay, scanners are more like cursors in a traditional database. As I was explaining to you that once you get to a particular row, you can get the next row and so on. That's done via cursor scanners. So scanners returns rows in the order of row key. Users obtain scanner by saying result scanner rs equals to htable.getScanner, and then you give the reason, give an argument called scan. Scan is essentially the starting of the row, ending of the row, basically where to stop, where to start the row key scanning, and which columns to return as part of the result, and a filter to run on the server side. Okay, a filter to run on the server side. Sometimes you may want to run some logic on the server side itself before getting the results. Okay, so you can run that filter on the server side itself by specifying scan. All right, next is every time we say give me next rows, it is going to make a trip to the region server. All right, if you are interested in understanding how you talk to HBase through Java, you can take a look at this code. You first create the config object, then you get the admin handle on the config object, then you basically create a table description, and on top of this table description, you have column description. So column description has column family and you are adding column family. So it's quite comprehensive. You can see that. The important part is that you can add every row is basically contains the put. Okay, so you basically put the data, get the data. So the API might look very, very primitive to you. Okay, so you can see that. So get and put is what it contains. All right. So all right. So HBase provides a Java API to write MapReduce. Just the way we wrote MapReduce to churn the data in a usual manner, in the same way you can run MapReduce as you can run MapReduce over HBase. The only difference here is that the input data to your mapper is each row, and row contains row key and the column definition, all of them. Okay, so for each row in HBase, your logic of MapReduce mapper would run, and then whatever is the result of your mapper will be aggregated based on the key value provided by the mapper. All right, so you can see that we create the MapReduce exactly the way we created the MapReduce in our usual case of churning the file. Here we are trying to churn a table. We are saying my mapper extend a base class called table mapper, and it's going to give out this key and this value. Okay, it's going to generate key value where key is going to be text and value is going to be integer. All right, and by default you are going to get row in the method called map as the input, and the value is going to be of the data type called result is nothing but the column details of each row. Okay, and in context you will write your key and the value. All right, exactly the way we did the MapReduce earlier. Then you create the reducer by extending table reducer, and your output is going to be contain the row key and the data from the data type of the columns. So you can see that here we are saying put.add. Here we are going to say the row key out of after we are producing the output. We are saying that we don't need to specify the row key. Instead, I want to give out the column family name and the count and so on. All right. So this is what a MapReduce looks like, and afterwards you stitch it together and then execute the MapReduce job over a source table for a small selection of scan, and then you provide mapper class, reducer class, and so on. All right. So that's about MapReduce over HBase. All right. So okay. So we have consumed 3 minutes extra. We will take a break now. All right. So see you tomorrow. That's pretty much for today. Okay. So tomorrow we are going to discuss a little bit about Bloom filter and the normal APIs. Okay. Thank you, everyone. Have a good day. Bye bye. Yes, Sukhvinder, I reviewed your questions. I reviewed your big questions and I have assigned marks, except except for the last question, where I was expecting you to use left join. Rest is great, absolutely great. All right. All right. Great. Great work, everyone. Prabhu's question is, can you provide some document regarding Storm, Kafka, and Accumulo? I can provide you regarding Kafka. Storm and Accumulo would be difficult right now. Oh, Vivek was not able to hear for last 2 minutes. No worries. I think everybody else was able to hear. So Storm is a stream processing engine. Kafka is a big queue. Accumulo is a security layer over HBase. All right. Sure, sure. All right. Great. Great. It was a great session. I mean, good set of questions you have asked. All right. And talk to you tomorrow. Bye bye.